So here we have an iPhone 13 Pro Max that's water damaged, and take a look at how bad it is. It is rusted out everywhere, and our goal here today is to actually repair this just enough so it turns on. We could unlock the screen and plug it into the computer to run an iTunes backup, and then from there we can get the customer's data like the pictures, videos, contacts, texts, all that information that is trapped inside this phone. There is literally no other way to get data from these type of situations, only to repair it so it turns on. So hi, I'm Jesse from VCC Board Repairs. We specialize in data recovery. So if you need your data recovered, I will link to my website down below where you can contact me for a quote. So let's go ahead and get started with this job. So here's the phone. Let's open it up. I've already taken off the screen and most of the screws are already removed. As you can see, it is in totally bad shape. So good news is I do have known good parts. So the goal is to first get the motherboard out. We get it fully disassembled. We can then use my parts to continue the data recovery. So first thing is let's get this out of the housing. So let's unplug that. So none of the parts in this phone really matter as far as the parts you can plug in. So I don't really care about any of that. Let me just get this board out. There's a little SIM thing here that gets in the way. I push that out of the way, and here you go. Now here in the US, we have a little 5G flex that wraps around the housing. Normally for repair, we would just we'd have to take out the battery so we can unscrew the plates here. But in this case, it's data recovery, so I just went ahead and ripped off this flex because we don't need it, and we just need to get the board out. We need to isolate this board from these terrible parts. And now we can continue with the journey to get data from this phone. Next, let's get the sticker off. There's a giant sticker here, I guess to protect the motherboard, but we don't need it, so let's get rid of that. Essentially, one way to think of it is kind of like just get everything that we don't need out of the way, so we can we need the bare minimum for this to turn on. So for these models, we actually don't even need the bottom board. This is actually a 2-layer motherboard. You can see they're stacked together, and we only need the top one because the top one has the memory chip, which is called the NAND, and then inside here is the CPU, which we also need. There's a few other things we need, but those are the main things that we need for data. So here, take a look at the board. So you can see there's like rust. That is not good. You never want rust on electronics, but here we are. So let's go take a look under the microscope. All right, so this is all in bad shape. So let's peel off all these stickers. We don't need them for data. So whenever people say, they put their phone in rice, one thing to consider is rice isn't touching any of the liquid, so it's not going to absorb moisture from externally. I think a lot of people who put their phone in rice and it works probably would have seen the exact same results if they just waited and let the phone dry. There's no way rice actually can absorb moisture from out of the air or from externally from somewhere else. So take a look at this LCD connector. You can see it is in really bad shape. We're probably gonna have to replace this. Like that's really bad. You can see like all the different damage. Now if I use my polarizer light, it makes corrosion and all that glow. So I'll link to this polarizer light down below as well, so you guys can check that out. Here's that 5G flex that I ripped off. It's not needed, and we're gonna get rid of the bottom board anyway, so. All right, so now we can see here's the situation. Now one thing that's concerning is this chip here is one of the chips that is needed, the EEPROM. This is paired to the CPU, and the CPU, this, and the memory all kind of work together to turn on and access your data. So if any of those are bad, there's no way to get data. Sometimes NFC as well, but I don't know. In many cases you don't need the original NFC. In some cases you do. I think it has to do with Apple Pay. At least that's what Greg Wade theorized, which kind of does make sense. So if you have like Apple Pay set up with credit cards, NFC has to encrypt some data, I guess, for security purposes. So I guess it adds extra layer of protection within that chip. So now I'm using isopropyl alcohol to kind of clean up some of the corrosion, especially here on the connectors. Let me just kind of clean up the external areas. I'm not going to check for shorts yet, because visually you could tell it's in really bad shape. I'm certain there's like a million shorts on this board. So let me just at least clean it up. Alright, this connector doesn't look that bad anymore. Maybe I lied. I see a really rusted out pin here. So usually from my experience, what I've seen is anywhere there's like electricity, a lot of electricity, is where you see the most corrosion. So like on VDD main, you see a lot of corrosion on basically anything that has power flowing all the time. Whereas like on some pins, there's nothing. Like this charging port, take a look. Charging port connector looks very clean, because unless they had it plugged into charge, there's nothing really happening there. The battery connectors often get destroyed, but that one actually doesn't look too bad. So now that we've kind of reviewed the outside, let's take a look at the inside. So I'm going to use this hot plate heater. This is let me turn it on. The X360 version 2. It is a really great heating platform that is no longer produced, but we need to set this to 235. At least on mine, I use 235 to split this motherboard. Now on 12 series and 13 series and newer, these require higher temperatures to split this motherboard, so it does make it a little more difficult, a little more tricky. And let me take out the sticker here. So this is the NAND. This is, think of it like the hard drive or the memory of the phone. We cannot just read the data off this NAND. The data is encrypted, which means all the data in here is jumbled, and it needs these special keys, encryption keys, to be able to decrypt the data. And those keys are spread across the EEPROM and the CPU. At least that's my understanding of it, as to how it works. But basically, long story short, is that you cannot read the data directly from this chip. It just does not work. If you do read it, it's just going to be jumbled data, and you're not going to be able to get people's pictures or anything off of it. So yeah, now we got to do is just wait. So let's give it a few minutes for this to warm up. We have to wait till this reaches 235, so we'll be right back. All right, so it's getting real close to reaching the melting point. So at this point, what I like to do is spread some flux in between the sandwich, wherever spots I can reach, like that. And this will allow for a smoother separation. Anytime you're doing any soldering, you need flux, and that's what we're doing here. So I'm just rotating the board and feeding the flux into it. Now you may notice there's a lot of fumes coming out. So definitely, if you're going to be doing this, have a good fume extractor. I'll link to the DIY setup I'm using. It's working really well. I don't know if you guys can see, but it is sucking up all those fumes real easy. It's almost nothing going to my face, but there you go. It's reached temp. I'm going to separate, and look at that. It actually looks not that bad inside the sandwich. So on the bottom board, you can see it's very clean actually. So this is promising. It does raise the chances of a successful data recovery. So now, put that out of the way, let's take a look at this board. Oh wow, look at that. So we see some corrosion here, which we gotta clean up. But all in all, this is pretty good for, you know, like the outside looks really bad, but the inside actually is not that bad. Oh, there's definitely some damage here. Take a look at that with the polarizer lights. Definitely, if you're a repair technician full time, I highly recommend it. This polarizer lights allows you to see stuff you normally wouldn't be able to see. Look at that. Let's see what else. All right, there's some corrosion under Kraken. This chip here is called Kraken. Some people will mistakenly call it Hydra or even U2, which is the wrong name for this chip. Let's get rid of this thermal paste. We don't need it. All right, so right now we're basically just doing a visual inspection, see what kind of we're going to be dealing with. So let me just scrub all this out. But the main points that I'm seeing is corrosion here, corrosion under Kraken, corrosion here, and a little bit over here in the corner. So if we have any issues, that's kind of where we want to double check. But first, let's clean up this board. There's a lot of corrosion here on these pads. Since there's a lot of corrosion on the pads, I'm gonna use the heater as kind of like to kind of rest the board on. So the heat will soften up kind of what I'm trying to clean here. Make it a little bit easier. I'm trying to clean off the flux and also kind of clean up the corrosion that's on the pads. Because corrosion is conductive, which means is electricity can flow through the corrosion, essentially creating a short, like the corrosion becomes kind of like a wire where it can transfer electricity, and you don't want electricity to go where it wasn't designed to go, basically. So we got to clear out all that corrosion, either just by scrubbing or by removing components. Now, I don't recommend, if your data is really important, I don't recommend you try this yourself. There's a lot of things that can go wrong if you don't have the right equipment, if you don't have the expertise. You could be damaging stuff inadvertently that you don't realize. So if you do need this service, reach out to me through my website. I'll send you a quote right away. I usually respond during the day within 30 minutes to an hour. We're here in Las Vegas, Nevada. We accept mail-ins across the country. I don't necessarily do international, but I may consider it. Let me clean off these pads. And by the way, what do you guys think of my new 4K microscope? I've been using it for the past few months, and it looks way better than my last one. So I'll link this down below as well if you guys want to upgrade. You do need a 4K capture card, or I guess use it via USB, but I'm using it with the 4K capture card. As you can see, it looks great. So I'm just trying to clean off any corrosion that didn't come off with my toothbrush. Alright, so I think I got most of it. Alright, so let me dry it out. So everything I'm doing right now is kind of just my preliminary steps. just like the baseline things I do. Basically clean up and isolate all the unnecessary parts. I think I just saw a component fly away. So now that we've done all that, now let's actually start troubleshooting. So one of the first things I like to do is connect this to a DC power supply. This will tell me if there's any shorts on the board. So this is a DT880. When I push power, it now outputs power to the cable, which is 4.1 volts. And this is a iPhone 13 mechanic iBoot cable. So this is designed specifically for iPhone 13. It also works on 14s. So what we're gonna do is plug this in while it's off. We're gonna see what behavior do we see on here. If we get any current draw before we even try to prompt to boot the device, that means there's a short on VDD main. If we don't, then we prompt to boot and then see if there's a short after, and that will tell us there's a short on other lines. So let's first start off with before prompt to boot, and oh, look at that. There's no shorts before prompt to boot, so that's a really good sign. Next step is to prompt to boot. Now, let me see how I can show you guys what I'm doing here. I'm gonna pull up ZXW. This is a board view software. This allows you to see how things are all connected to each other. And if you want to buy the software, I also have a link on my website, vccboardrepairs.com/ZXW. I have a full tutorial on how to buy it, how to download it, and all that. There's a lot of people who have issues with that, so I made a tutorial on that. So iPhone 13 Pro Max. All right, so here on the left are the models. I've been trying this recent history. Let's go to iPhone 13 Pro Max, and I'm just gonna select the core. This is the, oh great. All right, you know what, let's use something else. I'm gonna use JCID Drawing. This is basically the same thing, just as a different company. I prefer ZXW just because that's the one I started with. This is kind of like the OG software, and then all these other companies started making it. I just like the look and feel of ZXW. It's a little more user-friendly in my opinion, although JCID does have a little more information like schematics and stuff, although it's a little finicky sometimes. So let's go iPhone 13 Pro Max. Now this one does pull up some useful information. Let's see, how do I minimize here on the left? Would you like to download the latest? Yes. So on the right is kind of well, it's in Chinese, so you do need to use the Google Translate. Well, you need to find the power button. And then, so here on the power button, where the power button physically plugs in, there's these pins here. How do I close this? There we go. You like double click somewhere. So one of these small pins is gonna be the power button line. I don't know which one. So the trick is just try them all. And essentially we're gonna short each pin to ground until one triggers the device to try to prompt to boot. So if we go back, I'm going to just, using metal tweezers, so there's continuity from one end to the other. I'm just gonna touch one pin and see. All right, nothing. There you go. Look at that. It looks like it's prompting to boot, and wow, look at that. It's actually booting up. Now the question is, sure, it might look like it's booting up because we're getting current draw. This is like a normal boot up current draw, but as you guys saw, the LCD connector is destroyed. So let's take a look to see. Let's bring out my thermal camera. This is my Seek Compact Pro with macro lens. I'm gonna see if there's any heat on the board. So I wanna make sure there's no shorts that might not be obvious. yeah, I mean, it all looks good. This is just normal heat from just the phone trying to boot up. All right, so let's plug in a screen and see if we get image. So essentially we're gonna do one step at a time. So the current draw looks like it's booting. So now let's plug in a screen and see if it boots. So I'm gonna plug in a screen and I'm just gonna plug in only the screen. So same thing, I need a prompt to boot the device. So I'm gonna fold the screen over to the side and I'm gonna use ground, which is the shield, and then touch one of these pins right here. There you go, prompt to boot. And the trick with this model is, you see how it's hanging at 122? We want to let go after it jumps past that, and it should keep going. Look at that, it's kind of hanging there. Oh, there it goes. So that's more normal. It just kind of slowly ramps up, but it looks like it's not getting any image. I'm gonna press on the LCD connector, see if anything happens, and no image, no nothing on the screen. Most likely the LCD connector is damaged, so let's go ahead and see if we can repair that. All right, so I've put this board on a board holder, and now we're gonna start off first by removing this connector. And I can imagine there's gonna be a bunch of pins here that are like rusted out. Hopefully the pads underneath are still good. If not, I might have to even run jumpers and repair the pads. So I'm gonna use 380 Celsius and 50% air on my add-in hot air station to get this connector off. I'm gonna do it as is. I'm not gonna add any solder to it. So just go in circles. You just wanna go fast left and right. So the goal is to get this connector off. And just pay attention to the solder joints. You'll see when they start melting. There you can see I can wiggle the connector, and then any second now I should be able to lift it off. Let's go, almost there. Being stubborn here on the left side. There it goes. And we're out. So I'm gonna add some more flux. And then run my iron over it. Alright, so I did see one rusted pin. Looks like I'm able to fix it just by running my iron over it. I'm gonna rotate this. Essentially we're adding our own solder. This is low melt solder. It has a melting point of 183 Celsius, whereas the factory is like 226 or something. I don't know, who wants to correct me? The factory solder's melting point, which is unleaded solder. This is leaded solder. All right, there it goes. Let me go ahead and clean this up to see how the condition of the board and the pads. And blow it away. All right, yeah, look at that. All the pads are there. Now I do see some of that underfill, this black stuff, real close to those pins. I'm debating if I should try to clean some of that out or just leave it. You know, my OCD is it OCD? Yeah, OCD is bugging me here, so let me make some room. I'm using 250 Celsius to clear underfill. Alright, I think that should be good. Alright. By the way, if you support these videos, make sure you check out my locals community. That is my little private community group. I post there several times a week about the different repairs I'm doing and give a breakdown of what I did. actually post these videos at least one day before or one night before I post them live on YouTube. So if you want to see the videos earlier, check that out. It is I forget the link. I'll post it down below. I think it's vccboardrepairs.locals.com. All right, so we have the connector ready to go, but now we need a connector. So let me get this board out and get this board here. This is a donor board, which I've already tampered with, so it's good for parts. And we're basically gonna do the same thing. We're gonna extract this connector, but we need to remove it without damaging it. I don't have another one readily available, so this is kind of a one-shot situation. So the trick to these is when you lift it up, you pull away your hot air instantly. You gotta do it like at the same time, because as soon as the connector is off the board, the thermal mass of the connector drops to almost nothing, so the heat will totally destroy the connector. Whereas when it's on the board, the thermal mass is being shared by the whole board. The heat spreads, it's not just concentrated on the connector. So look at that, it's coming loose. I actually have a video on 13 connector replacement. We go through the same thing, so want a more detailed process of that. All right. It's being stubborn on this end. The flux already all kind of went away. All right. Maybe get this left side disconnected. And I have to increase the temperature. And my flux ran out, so let me reflux the whole thing. Let me just increase my temp to 400 Celsius and 50% air, because that ground on the end needs to melt. And it looks like everything else is melted except that ground here on the end. I don't think this side on the right is not ground at the end. So let's see if we have better luck. Remember, I have one shot here, otherwise I have to go dig around for another connector. All right, here goes. So you see that? I pulled my hot air away from the board as soon as it came loose. So this will be perfectly straight, as if I bought it from China, but I didn't. This is a OEM pull, as we like to call it. All right, let me put the data board back. One of the nice things about using a pull versus a brand new one is the pins have solder on them, so it makes it easier to install. Actually, wait, before I do that, I almost forgot. I need to wick the pads at the end, the ground pads, or just the big pads at the end. This will make it easier to install the connector without having to, basically allows the connector to be installed flat. If I don't do this, these pads here at the end might be raising the connector higher and not make contact with the center, the smaller center pins. So you gotta work this flat, kind of like that. And like that. All right, let's add some more flux. So the thing about data recovery is this is kind of how it goes. you really need to know how to handle every type of soldering scenario, whether it's replacing connectors, running jumpers, dealing with sandwich boards. You have to be able to do them all, because it like finding shorts, injecting voltage, basically every micro soldering skill there is, you have to know. You have to be a master at it so you can successfully do these data recovery jobs, because you never know what issue is going to be present and which one you have to tackle. So this is something you do once you have leveled up to this point, and you can do these other jobs without any issues. Alright, so connector looks like it's installed. So I'm looking at the connector pins, the solder joints. Keep in mind, we have the CPU on the other side. We have the NAND right here. So you got to be real careful when dealing with these, especially if this is data recovery. You have no going back if you like damage something. So don't practice on customers' boards. Alright, so oops, that's a big solder ball. I'm just putting a little bit of solder on my iron so I could anchor in these ends. There's very little room, so I'm using my conical tip on my action soldering iron. Alright, let's get some solder there. Some solder there. Just because when you plug in the screen, this can be loose, and then you could damage the connector, and now things aren't working. So, because I'm on this board holder, it's going to be hard to tilt the board to check the pins. So let me clean it up, take the board out, and then inspect. Also, notice a lot of flux here, so let me make sure I clean this out. This is where the battery plugs in. Oh man, that's a lot. Let me apply a little bit of heat. So I'm at 250. Flux, when it cools down, it becomes very not solid, but very viscous. So it's very hard to clean. So that's why you got to warm it up a little bit. And then hit it with the alcohol. Alright, let me get some of this gunk out of here. Alright, let's see. Alright, so let's inspect the pins. What do you guys think? Rate in the comments what do you guys think of my FPC replacements on a scale from 1 to 10. 10 being the best, 1 being the worst you've ever seen. I think it's pretty good. I would give myself a solid 8. 8 out of 10. Maybe 7. Good news is we only need data from this, so if the pins are a little dry, so to speak, not enough solder, then we just need enough for data. So let's go ahead and hop over to this other area. Let's give this another try. So DT880 is off. We're gonna plug in the screen. All right, the screen clicked. That's a good sign. That means, uh-oh, they're short, or this die. Yeah, there's a short. So when the DT80 turns off, that means there's too big of a short. So let's figure out what happened. It could be the corrosion somewhere else has finally caved. So let's take a look back over here. I'm guessing something here probably finally gave out. What happens with liquid damage is shorts can come and go. Let me just inspect the board. And there's nothing I could have caused. No way I caused a short here because nothing is touching. All right, so now let's measure for shorts. So this is kind of how data recovery ends up is you think you're good, you're about to go for it, and then you discover a short. So first thing I would do is check for VDD main. Since ZXW nor any other board view software have the net names, which means we don't know what, this is how generic names, net, new net, u, something, like different codes. But I know from experience that VCC main, VDD main is always going to be around PMIC, and I know PMIC is always a big chip that has a lot of coils around it. So here, this is VDD main. So this measure for a short. Oh, look at that. If we come here, this is where that corrosion is on the top that's really rusted out. So let's measure that area. Oh, look right here too. I remember seeing this cap looks a little funny. All right, this is a CPU, this is a PMIC, this is the NAND over here. So yeah, let's check these areas. Basically, if any of these red points reads as short, then the whole circuit is shorted. The VDD main is short. So you cannot find a short just by probing. You have to first detect it, and then you have to find it. And you find it using a thermal camera. So take a look. So let's measure this giant cap here on the upper right corner, which is this one here, which I noticed looks not so good. Usually when a cap is shorted, it should not be black pads. It should look more like these. See how these have silver, shiny silver pads at the ends? This one has black on black. So diode mode is what we use. Highly recommend this multimeter, the Fluke 115, because it has beeps for many different scenarios. So right now I'm in diode mode. On my multimeter, I'm gonna put red probe on ground, so like this chip, and then the black probe, I'm gonna start probing around. Look at that. So I have a 0.309, and it gives me a short beep. This side's gonna be ground, so yeah, that's good. All right, so we don't have a short on VDD main, but just kind of for reference, we're gonna probe around. So this line is gonna be 0.329. 308, 329. So I'm trying to find the short. Essentially, you know something is shorted when you have a cap reading ground on both ends. So long beep. But don't use beeps. It's really bad approach to saying like, oh, this beeps, so it must be short. It's better to look at the diode mode reading. All right, so if that's not shorted, what is shorted? Or is it my DT80? Let me check the cable. This cable is kind of beat up. I don't see why that would cause a short. Let's check the battery connector. So with battery connector, there's always going to be a positive and a negative on a battery connector. So one is going to be like bat VCC, the other one's going to be ground. So ground, ground. Yeah, so the short is going to be here. Usually when you have a short here, or like on the DT80 or DC power supply, you have a short before prompt to boot is usually VDD main. It's pretty rare short is on actual the battery line. But let's take a look. Is there anything here that can cause it? Is there anything nearby? Maybe something under the shield. I don't see any visible corrosion in here. One of the things I like about this mechanic cameras versus some of the other cameras, microscope cameras on the market, is that this has really good auto exposure. So it adjusts the brightness based on what's in view. So it's always like clear. So you can see there it's clear. If you go into somewhere dark, it brightens up. If you go somewhere far away, like it adjusts on its own. So that's why I recommend the mechanic cameras. Even the 1080p one, the old one, that one's pretty good at that as well. But the 4K one is so much nicer. Yeah, I mean, I can see a cap in there, but it doesn't look corroded. All right, so I guess time to go a little further. Let's go back to the board view software. So our short is actually on this line. Oh, look at that right here. So short can be anything that's in red, because this is what's shorted. So this could be, well, not this, because there's no ground. Unless there's corrosion here shorting this to ground. Could be this chip that failed, or here. Wow, there's not much. Maybe some of these pads are corroded. Let's take a look. Maybe this chip got damaged. All right, let's go. This is weird. There's not much on this circuit. So, only thing I can think of, because it was working fine before, so let's see. Yeah, it's either these pins, one pad under this chip, and those, or under this. All right, let's go back to the battery connector. I mean, it looks good. Yeah, full short, 000. Ground is 000. All right, so now we go to injecting voltage. All right, so now we have multimeter probes that are connected directly to my DC power supply. I have now turned on, so it was set to 4.2 volts, 2.5 amps. So when I short these together, you can see we get 2.5 amp draw, let them go 0. So we're gonna inject voltage into here while looking under the thermal camera to see where the heat comes from. So when you do this, you wanna inject, you wanna put black on ground, so I'm gonna put it just on the NAND, and then red on the positive. So we're gonna inject it into the top battery pins, and you can see I'm getting full 2.5 amps, but nothing obvious as to culprit. So take a look. The probes heat up, but it's very weird. What could have caused this short? Nothing obvious there. Now if we flip it over, and we go back to on this side, so any of these corner pins are this line, the battery connector. So let's give it a same thing. Black goes on ground, so any of these silver chips And then red goes into one of these corner pins. Oh, I see it. You guys see that? Alright, so one of the benefits to the Seek stand camera setup is I could adjust the height. Get real close to, alright, I just gotta focus the camera. And now you can see a clear image of the board. Which is weird because I didn't see this component there. Alright, let's inject again, same thing. Black on ground, red on these corner pins, pads. Look at that, you guys see that? So the spontaneous short that appeared out of nowhere. So I basically, you can see the heat corresponds with my DC power supply current spiking. So one of the things, if you're doing this and like you're busy looking at where you're injecting, because you do have to be careful when you're injecting. You know, this is a battery line, so we're injecting what a battery voltage would output. So this is why I'm using 4.2 volts, because a battery, fully charged battery outputs basically 4.2 volts. Any of the other lines, you do have to be careful. You don't want to put 4.2 volts on a CPU, 1 volt line or something like that. So if you're having trouble seeing the short, what you can do is you swipe here, you click record, and then you could go back and watch it to see exactly where the heat's coming from. But I am looking, oh wait, hold on, get the in view. So there's some IC there and it's like on the corner. So let's take a look under the microscope, see what that is. Now I do get a lot of people saying how they want to use this under the microscope. And oh, look at that, I see it. They want to use a thermal camera under the microscope, but I don't have, my stand does not support that. But I am considering an adapter you can attach to your scope. Oh, I see what happened. This little solder ball squeezed out while replacing the connector. So, little stray piece of solder ruined my data recovery. So now let's take a look with my multimeter. Don't confuse this from my DC power supply. Let's see if I brought back, clear that short. Look at that, short is gone. Before I was getting 000, now I'm getting 397. Therefore, should be good now. But yeah, I like this setup, thermal camera, just because of how quick I can set it up. Like, it's literally just this. As soon as I'm done, I put it off on my little shelf here and we're good to go. Like, everything I like the DT80 is so compact. This is literally it. I don't have obviously I need a DC power supply, but I prefer this. I have one main unit, one cable, and that's it. Whereas any of the other DC power supply adapters, I don't know why China likes putting multiple cables on one plug. Why do that? Just put one cable per plug. But whatever. Let me know down below in the comments if you want me to make my own DT80, because these are no longer in production. So I might have to just make my own, because nobody ever besides DT80 made this solution where it's one cable and multiple plugs. They have multiple cables with one cable. Anyways, all right, short's gone. So we're back at 0. Now there's always going to be that 56 milliamp kind of draw at the beginning. I don't know what that is. I noticed that happened with a more recent DT80s, but it doesn't matter. As long as it settles at 0 volts, they're good. 0 amps. All right, so let's try to prompt to boot using the tweezers, shorting, I think it's this pin here. Oh, I missed, can't aim. Trying to keep that in view as well. This pin here, there it goes. Current draw is up, it's hanging, keep holding, 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 holding. Oh, I didn't. See how I went to 0? It's because I wasn't holding it right. All right, let's try again. Hold. Hold. As soon as it shoots up, let go. Oh, I'm not holding it right. There we go. It jumps to 250 and we have image. Now this screen is my known good damaged screen. Besides this impact zone, everything else is good. Touch works everywhere else besides this little area, but I've noticed I'm able to touch pretty much any pin. Let's see, what is my pin code here? Look at that, Kobe. And we have touch, and we can unlock the screen. So let's go ahead and type in the pin code. Look at that, we are in. Now, we're not at the finish line yet. There's still a few more things we gotta do. The device is gonna restart in 3 minutes because it does need known good charging port plugged in, and 13 Pro Max also needs the ear speaker flex plugged in. Without these, it's gonna restart, so it's not. The good news is that we have functional booting phone. So let's turn this off. Now to get data, we need to plug in a charging port. All right, this is what you need on a 13 Pro Max. I wrote an article on the repair wiki on this, so if you're ever not sure, go to repair.wiki. That is the name of the website. You type that exact words in the browser, repair.wiki, search iPhone 13, and you'll come up with the what causes iPhone 13 to restart, and I write down kind of a whole explanation on that. So we need charging port, battery, screen, proximity flex here at the top. You need all those plugged in, otherwise the phone's gonna restart. So I'm gonna plug this in to the cable to the computer. This should prompt the device to boot, and once we unlock it, then we can get data. If you have a phone that has no touch, you cannot get data from that phone. You need touch to unlock it. Type in the pin code, because when you're typing in the pin code, you're basically decrypting the data from the phone. This will allow you into the phone. And we're in. Now, you're gonna get a bunch of pop-ups. Click OK, trust. All right, we're getting a bunch of error messages. Let me turn on Do Not Disturb so I stop getting pop-ups. As you can see, nothing is working because all the Wi-Fi baseband, some other stuff is on that bottom board. So what we're gonna do is use 3U tools to back up the phone. All right, so using 3U tools, I'm running a backup. This is gonna take, looks like we have about 199 gigs of data. This allows me to do a backup. This is just a standard iTunes backup file. It'll work on iTunes as well. Although I've noticed, at least on my computer, I don't know if it's widespread, but I noticed iTunes, even if you back up a phone on iTunes, that backup is not detected by iTunes. Like it literally doesn't see it. It tells you like it's never been restored. I don't know about that, but 3U tools does work. So once I get the backup, then I use this program called GeoSoft iTunes Backup Extractor. This allows me to scan the backup file and extract the pictures, videos, contacts, text, notes, voicemails, call logs, like everything, and gets that data into, it's basically one-click thing. So you don't have to manually go to each type of data. It's like one click, scans it, click again to once they finish scanning it, to like approve or to select where you want to save this data, and then it has all that information that you can view on a computer. This is not, I mean, it's just the raw data, so it's like in JPEG files and text files, spreadsheet. If it's a contacts, it gives you like multiple formats. And this software is not free. It's one of those softwares where like the web page makes it sound like it's free, but once you try it and actually use it, you do have to pay. It's like 35 bucks, but it's definitely worth it. So this is what I use 99% of the time. Sometimes this doesn't work, for whatever reason. Then I'll have other programs like iBackup Viewer, Alt Data, ULT Data, I think that's the main ones I've used. But now we gotta make sure this phone does not restart. As of now, it is not restarting. We're still connected, and it looks like it started the backup. All right, so it feels like it's been way more than 3 minutes. The phone's not restarting. So at this point, it's pretty safe to say that this is gonna successfully back up. You know, it is 2:15 a.m. right now, so I'm just gonna let this back up overnight, and tomorrow I'll be able to scan it for the data, and then the job will be done. So once the backup is done, you're pretty much set. So you know, that's the good news. Also, one more thing that I always forget to check is open up iTunes to check whether this phone has a backup password set up. Let's see if I bring it over here. iTunes will, 3U Tools doesn't always detect it. I've had several cases where it's backing up fine, it goes all the way through, and then when I try to scan it, it asks for the iTunes backup password, or like encryption password for the backup file. And there's ways to remove it by going to your settings and reset all settings. Reset all settings, not reset data or reset. Reset all settings does not wipe your data. It just resets a few things within the device settings. It just wipes the backup password. So let me just show you guys, because I don't want anyone to blame me for wiping their data. All right, so you go to General, you go to Transfer or Reset Phone. Right here at the bottom, click Reset, not Reset All Settings, Reset, and then, oh, you guys can see it. All right, because the screen's all busted. So the very top one, you cannot see, will say Reset All Settings, and it'll prompt you many times that, like, hey, your data's fine, your media is not gonna be wiped. So just wanted to show you that real quick. But as of now, and then iTunes always takes forever to connect to the phone. And this phone is taking forever to back up. But it's definitely not restarting. So this is good news. It'll just eventually back up. All right, there it goes. It's now moving. It just takes forever. But yeah, if you open up iTunes and you can connect to the phone, like it's not letting me, there's a little checkbox here under the, like, where do you want to back up? It'll be iCloud, it'll be like this computer, and then there'll be a checkbox saying encrypted backup, and then you can set a password. You know, without that password, you cannot do anything with a backup file. I've tried programs where it scans, where it like tries to brute force the backup password, and ran it for, you know, over a week, and it's still nothing. So I just gave up. You have to remove that password if you want to be able to scan it, or you have to know the password. So many customers don't know that, so something to keep in mind. All right, so there you have it. This iPhone 13 Pro Max, although it was physically pretty bad, like if you see this kind of rust on the housing in the parts, usually it's a bad sign, but luckily this one wasn't too bad. We were able to do it successfully. You know, I don't recommend you try this yourself. There's a lot that goes on. There's a lot of practice, you know, trying to maneuver the board under a microscope and handle all these parts. It does take practice. It's not something you just are naturally good at. So don't try it if you've never done any kind of soldering. Reach out to a professional like myself. So I will link to my website down below, so you can contact me for a quote. I respond pretty fast. And if you enjoyed this video, make sure you like the video, subscribe to the channel. I have a lot of cool links down below, like the repair wiki that I mentioned. All the tools from my video are also linked down below. I actually just updated my website with all the recommended tools. I added the add-in hot air station, the action soldering irons, and some other stuff as well, so check that out. Don't forget, I also have a locals community, so if you want to support the channel, that's one way to do it. Another way is to get t-shirts like this one, whether it's my logo or some of the other repair related t-shirts. So appreciate all you guys who stuck around here to the end. Check out this video here where I do another data recovery on a water damaged iPhone 6. Appreciate all you guys. So I'll see you on the next one.